Hello everyone. Today we'll be solving AQA GCSE Chemistry June 2022. This is foundation paper. We're going to be solving this particular video's second part. We're going to be solving from question number 5 to question number 7. A student investigated the reaction of magnesium with hydrochloric acid. Figure 7 shows the apparatus used. We can see stopper, conical flask, 25 cm of hydrochloric acid and a gas syringe. Set up the apparatus as shown in figure 7. Cut 10 mm of magnesium ribbon. Remove the stopper. Add the magnesium ribbon to the conical flask. Replace the stopper as quickly as possible. Record the final reading on the gas syringe when the reaction has stopped. Repeat steps 1 to 6 3 more times. Alright. Repeat steps 1 to 7 with different lengths of magnesium ribbon. Yeah. So maybe next experiment uses 15 millimeter. Or the next experiment uses 20 millimeter. Okay. Alright. And the purpose of repeating steps 1 to 6 3 times is to get an average. Okay. We replace the stopper as quickly as possible so that gas cannot escape. Okay. Alright guys, so let's move on. Which gas is produced when magnesium reacts with hydrochloric acid? Guys, we need to know this basic equation. When we add an acid with a metal and there is a reaction, we get a salt and we get hydrogen. So in this case, the gas will be hydrogen. What was the independent variable in the investigation? Guys, in this investigation, we have used variable lengths of the magnesium ribbon to repeat the experiment in later cases. So the length of the magnesium ribbon will be the independent variable. Give one control variable in the investigation. So in every experiment, we have added a fixed quantity of acid. So volume of acid will be our control variable. Table 5 shows the result for one length of magnesium ribbon. Okay. Alright, so trial 1, 19, 36, 37, 32. One of the result was anomalous. Guys, we can see 19 is way out of the original values. So this is an anomalous. Which trial in table 5 gave the anomalous result? Trial 1. Suggest one reason for the anomalous result in table 5. Probably the student was unable to close, because the volume of gas is less. So probably the student was unable to close the stopper, and so the answer should be written. Some gas escaped before the stopper was put in. Table 6 shows the mean volume of gas produced for each length of magnesium ribbon. Okay, so length 10, mean gas produced 7, 20, 14, 30, 21. Alright, plot the data in table 6 on figure 8. And then the question asks us to draw a line of best fit. So, alright guys, as the length of the magnesium ribbon increases, the mean volume of gas produced also increases. This question is about carbon and compounds of carbon. Figure 9 shows the diagram that represents different structures. We can see A, which is a fullerene. This is Buckminster fullerene. And we can see B, which is a cylindrical. We can see C, graphite, and we can see D, which probably is a polymer. Which diagram represents graphite? Definitely C. Which diagram represents polythene? Definitely D. Figure 10 represents the structure of diamond. We can see each carbon is bonded with 4 other carbons. How many covalent bonds does each carbon form in diamond? 4. Which is a property of diamond? Diamond does not conduct electricity, it does not have a low melting point, but diamond is one of the hardest material known to man. Figure 11 shows a model of a molecule. We can see carbon, we can see hydrogen. Complete the molecular formula of the molecule. So let's count the number of carbon. There are 2 carbons, and we can see a total of 1, 2, 3, 4, 5, 6 hydrogens. Carbonic acid is a compound of carbon. The formula of carbonic acid is H2CO3. Which ion is produced by carbonic acid in aqueous solution? Any acid produces hydrogen ion. Calculate the relative formula mass MR of carbonic acid. So if we have to calculate MR, we write, first of all, we write like this. MR H2CO3, then we multiply 1 times 2, then we have 1 carbon, so 12, plus 16 times 3, so the total is 62. This question is about small particles. Coarse particles, fine particles, and nanoparticles are all small particles. Which is the largest particle? Definitely coarse particle will be the largest particle. Figure 12 shows a cubic nanoparticle, 2 nanometer, 2 nanometer by 2 nanometer. The surface area of the cubic nanoparticle is 24 nanometer square. Calculate the volume of the nanoparticle. So to calculate the volume of the nanoparticle, first of all, we will have to multiply length into breadth into height. So 2 times 2 times 2, which will be 8 nm cube. Now they want the simplest surface area ratio with ratio of the cubic nanoparticle. So surface area was 24, ratio with the cubic nanoparticle, 24 is to 8, so it will be 3 is to 1. All right. So first of all, all right, here answer will be 8 nanometer cube and volume will be 3 is to 1. Catalysts made of nanoparticles are often more effective than catalysts made from normal size particles. Compare with normal size particle, the surface area to volume ratio of nanoparticle is, obviously nanoparticle can spread out in a large surface, so it will have a large surface area. So we can write higher, we can say larger. This means that the mass of a nanoparticle needed to have the same effect as the same catalyst made of normal size particle. This means the mass of the nanoparticle catalyst needed to have the same effect as the same catalyst made from normal size particle is obviously less, lower or less. Silver nanoparticle can be added to material used to make socks. Some facts about silver and bacteria are: silver nanoparticles are small enough to be breathed in. Silver is very expensive. Silver can kill bacteria. Bacteria can cause infection. Bacteria can break down sweat to produce unpleasant smell. Suggest one advantage and one disadvantage of wearing socks containing silver nanoparticles. So the advantage will be silver can kill bacteria. Even though silver can kill bacteria is an advantage. However, the better advantage is it stops unpleasant smell. Because it can kill the bacteria and the bacteria won't be able to produce unpleasant smell. The disadvantage of using silver, because we can breathe it in and it will be very expensive. Just as an additional point we can write, high cost of the sock, and in the advantage, an additional point could be can stop foot infection. Many of us may have a problem for athletic foot, so yeah, can be a huge relief. An atom has a radius of 1 into 10 to the power minus 10 meter. Guys, this is a very common question. So this is the atom's radius. All right. Let's just consider that this is the nucleus, by the way. I'll let you know why I have drawn it like that. 1 into 10 to the power of minus 10 meter. The spherical nanoparticle has a radius of 1 into 10 to the power of minus 8 meter. How many times larger is the radius of nanoparticle than the radius of the atom? Guys, when it comes to negative, a smaller number is a bigger number. So we can see compared to this one, so we can do it like this: 1 into 10 to the power of minus 8 divided by 1 into 10 to the power of minus 10. So this will, when we cancel out each other, all right, we will get an answer of 100. So it will be 100 times. Guys, that's all for today's video. Thank you for joining the video. And guys, please subscribe to the channel and watch the video from the beginning till the end if possible. All right. And if you want to support the channel, let your friends, let your school buddies know about the channel. All right. Regular videos are being uploaded, and inshallah I'll keep on uploading. All right, guys, just I need your help to make the channel grow. And best of luck to your exam. All right, thank you for watching the video. See you in the next video. Bye bye.